Welcome back. Thank you for joining me. So, we talked about reciprocal functions. Now we're going to talk about rational functions as a whole. Now, before we start thinking about graphing them, we're going to talk about the pieces of them. So the next two lessons are going to be discussing certain elements, certain pieces of rational functions before we actually start hardcore graphing them. So, the first thing is points of discontinuity. All right, so points of discontinuity. This is going to be where you would be dividing by 0. Okay, so that's kind of the main gist of this is you're looking at the denominator and you're seeing what would make me divide by 0. Now, there's a couple things that can happen. All right, oh, there we go. So the first thing that could happen when you look at the denominator is sometimes it will never be 0. Okay, so that's one of those cases that is always going to be a positive value. So if it can't ever be 0, we don't even have to worry about it. It will be what we call continuous. Now, on the flip side, something else could happen. So I'm focusing on the denominator, but notice that it cancels out. Okay, so that means that there's a hole at x equals -2. When you have the bottom there, okay, when you have the bottom and it cancels out, that is going to create a hole at that value. So here at -2, we're getting a hole. And then I want you to see in this one, we're focusing on the bottom. So this means at x equals 2, there's what's called a vertical asymptote. Again, we have to avoid what would make us divide by 0. So in this case, if we used 2, it would make us divide by 0. And we have to avoid that point, but because it doesn't cancel out, what that means is that there is a vertical asymptote. So that's kind of the basis of this is if it can't be 0, then it's continuous. If it cancels out, that creates a hole. And if it doesn't cancel out, that creates a vertical asymptote. So what do we do to solve these? Well, you want to factor both the numerator and the denominator of the rational expression. So if it can be factored, you need to factor it. You need to set each factor equal to 0 and solve. These are your points of discontinuity. Okay, and I should specify set each factor on the bottom. So set each factor on the bottom equal to 0. These are your points of discontinuity. And then you want to cancel any factors and use the table to determine the type of discontinuity formed. So in this case, when it cancels, you get a hole. When it doesn't cancel, you get a vertical asymptote. All right. So that's really wordy. So let's break it down. When you see problems, let's break down what do you need to do. All right, so here you focus on the bottom. So points of discontinuity, you always focus on the bottom. This piece will give you a discontinuity at x equals 2. This piece will give you a discontinuity at x equals 3. Okay, so you have to identify the pieces and what would make the pieces 0. So that's your first step. Now, your next step is to identify whole or vertical asymptote? Okay, well, notice neither piece cancels out. So because they don't cancel out, that means both of these are actually going to be vertical asymptotes. Again, that's what happens when you can't cancel. All right, now let's look at this next piece. Well, this next one, you can actually factor the top. So on top, you get x minus 4 and x plus 1 over x minus 4. Then those x minus 4s would actually cancel out. So when I'm looking at my bottom, I can tell that I have a discontinuity at 4. So that's the first thing that I label. I label where my discontinuity is, and then I label the type. Well, this time it canceled out. Okay? So this time I'm actually getting a whole. So again, that's the main idea here, is label where the discontinuity is and then what type it is. Now I did want to include this one again because I do want you to see that actually doesn't factor. And that, because it doesn't factor, that means that that actually can't be 0. Okay? So that denominator will actually never equal 0. It is always going to be a positive number. So because of that, remember we say that is continuous. There are no points of discontinuity because we never actually have to worry about the bottom being 0. So that's kind of the nice thing about that one. Now, that one turns out nicely because of that plus sign. This one over here, this one actually does end up factoring because it has x squared minus that number. Now, I hope you remember your difference of squares factoring. Difference of squares, remember you got your plus and minus relationship. Now, if that doesn't ring a bell, make sure to check in with me and I can refresh your memory on how to do that. But again, by this point, you should be able to factor. Now, from here, we need to look at our points of discontinuity. So, from that one, I have one at x equals negative 4. From that one, I have one at x equals positive 4. Now, notice neither one cancels out. So, because neither one of my points of discontinuity cancel out, what that means is both are going to be vertical asymptotes. Oh, there we go. Okay, so I have both of mine being vertical asymptotes, and that is going to be the end. So again, that's the focus of today. It's just, can you do vertical, or can you determine the points of discontinuity? What x values are they at, and what type are they? All right, so again, please make sure you have this all written down for me, and then make sure that you ask any questions if you have them.